Hello everyone, welcome to today's session. Today's topic of discussion of deep learning. Let's learn about deep learning. What is deep learning? You can consider the deep learning model as a rocket engine and its fuel, its huge amount of data that we feed to these algorithms. The concept of deep learning is not new, but recently its hype has increased and deep learning is getting more attention. This field is a particular kind of machine learning that is inspired by the functionality of your brain cells called neurons, which lead to the concept of artificial neural networks. It simply takes the data connection between all the artificial neurons and adjusts them according to the data pattern. More neurons are added, the size of the data is large. It automatically features learning at multiple levels of abstraction, thereby allowing a system to learn complex function mapping without depending on any specific algorithm. You know what? No one actually knows what happens inside a neural network and why it works so well. So now you can call it a black box. Let us discuss some example of deep learning and understand it in a better way. Let me start with a simple example and explain to you how things happen at a conceptual level. Let us try and understand how you would recognize a square from other shapes. The first thing you do is you check whether there are four lines associated with the figures or not. If yes, we further check if they are connected and close. Again, if yes, we finally check whether it is perpendicular and its all sides are equal. If everything fulfills, yes, it is a square. Well, it is nothing but a nested hierarchy of concepts. What we did here, we took a complex task of identify a square in this case and broke it into a simpler task. Now this deep learning also does the same thing but at a larger scale. Let's start an example of machine which recognizes the enemy. The task of the machine whether the given image is of a cat or a dog. What if we ask to resolve the same issue using the concept of ML? What we would do? First, we define the features such as check whether the animal has whiskers or not, a check the animal has pointed ears or not, or whether its tail is straight or curved. In short, we will define the facial features and let the system identify which features are more important in classify a particular animal. Now, when it comes to deep learning, it takes this to one step ahead. Deep learning automatically finds the feature which are most important for classification. Compared to machine learning, where we had to manually give out that feature, by now I guess you understand that AI is bigger picture and machine learning and deep learning are its subpart. So let's move on and focus our discussion on machine learning and deep learning. The easiest way to understand the difference between machine learning and deep learning is to know about deep learning is machine learning. More specifically, it is the next evaluation of machine learning. Let's take a few important parameters and compare machine learning and deep learning. So starting with data dependency. The most important difference between deep learning and machine learning is its performance as a volume of data gets an increase. From the graph below, you can see that when the size of the data is small, the deep learning algorithm doesn't perform that well. But why? Well, this is because a deep learning algorithm needs a large amount of data to understand it perfectly. On the other hand, the machine learning algorithm can easily work with smaller data sets. Next come the hardware dependency. Deep learning algorithms are heavily dependent on high-end machines, while the machine learning algorithm can work on low-end machines as well. This because the requirement of deep learning algorithm include GPUs, which is an integral part of its working. The deep learning algorithm requires GPUs used as they do a large amount of matrix multiplication operations. These operations can only be efficiently optimized using a GPU as it is built for this purpose only. Our third parameter will be feature engineering. Well, feature engineering is a process of putting the domain knowledge to reduce the complexity of the data and make patterns more visible to learning algorithms. This process is difficult and expensive in terms of times and expertise. In case of machine learning, most of the features are needed to be identified by an expert and then hand coded as per the domain and the data type. For example, the features can be a pixel value, shapes, texture, position, orientation, or anything. The performance of most of the machine learning algorithm depends on how accurately the features are identified and extracted. Whereas in case deep learning algorithm, it tries to learn high level features from the data. This is a very distinctive part of deep learning, which makes and way ahead of traditional machine learning. Deep learning reduces the task of developing new features extractor for every problem. Like in the case of CNN algorithm, it first tries to learn low-level features of image such as edges and lines, and then it proceeds to the part of face of people, and then finally to the high-level representation of the face. I hope that things are getting clearer to you. So let's move on and see the next parameter of deep learning. So our next parameter is a problem solving approach. When we are solving a problem using a traditional machine learning algorithm, it is generally recommended that we first break down the problem into different subparts, solve them individually, and then finally combine them to get the desired results. This is how the machine learning algorithm handles the problem. On the other hand, the deep learning algorithm solves the problem from end to end. Let's take an example to understand this. Suppose you have a task of multiple object detection and your task is to identify what is the object and where it is present in the image. So let's see and compare how you will tackle this issue using the concept of machine learning and deep learning. Starting with machine learning, in a typical machine learning approach, you would first divide the problem into two steps. First, object detection and then objective recognition. First of all, you would use a binding box detection algorithm like Grab could, for example, to scan through the image and find out all the possible objects. Now, once the object were recognized, you would use an object recognition algorithm like SVM with Hog to recognize relevant objects. Now, finally, when you combine the result, you would be able to identify what is the object and where it is present in the image. On the other hand, in deep learning approach, you would do the process from end to end. For example, in a YOLO net, which is type of deep learning algorithm, you would pass an image and it would give you out the location along with the name of object. Now let's move on, and our fifth comparison parameter, its execution time. Usually a deep learning algorithm takes a long time to train because there are so many parameters in deep learning algorithm that makes the training longer than usual. The training might even last for 2 weeks or more than that if you train completely from scratch, whereas in the case of machine learning, it relatively takes much less time to train, ranging from a few weeks to few hours. Now the execution time is completely reversed when it comes to the testing of data. During testing, the deep learning algorithm takes much less time to run, whereas if you compare it with a Canon algorithm, which is a type of machine learning algorithm, the test time increases as the size of the data increases. Last but not the least, we have interpretability as a factor for comparison of machine learning and deep learning. This fact is main reason why deep learning is still thought 10 times before anyone new uses it in the industry. Let's take an example. Suppose we use deep learning to give automated scoring to essays. The performance and scoring is quite excellent and is near to the human performance, but there is an issue with it. It does not reveal why it is given that score. Indeed, mathematically, it is possible to find out which nodes of a deep neural network were activated, but we don't know what the neurons are supposed to model and what these layer of neurons are doing collectively. So if we fail to interpret the results. On the other hand, machine learning algorithm like decision tree gives us a crisp rule for void, chose and what is chose. So it is particularly easy to interpret the reasoning behind. Therefore, the algorithm like decision tree and linear or logistic regression are primarily used in industry for interpretability. So let me summarize things for you. A machine uses an algorithm to praise the data, learn from the data, and make informed decisions based on what is it has learned. Now, this deep learning structures algorithm and layers to create artificial neural networks that can learn and make intelligent decisions on their own. Finally, deep learning is a subfield of machine learning, while both fall under the broad category of artificial intelligence. Deep learning is usually watched behind the most human-like artificial intelligence. So, thank you so much, guy. If you have any doubt, don't hesitate and add your doubt to the comment section. Thank you so much. See you later.